Number 3. This is a question I got a lot of questions on in class. How many particles are in 1 mole of carbon? 1 mole of lithium? How about 1 mole of eggs? Will 1 mole of each of these substances have the same mass? Now let's refer to the first portion. How many particles are in 1 mole of carbon? Well, if it's 1 mole, it's defined as having this number of particles, Avogadro's number. If it's 1 mole of the stuff, there's that number of things in that stuff, particles. Realize that particle is a very generic term. This can represent atoms, molecules, ions, anything generically. So we use a generic term like particles. There are this many, Avogadro's number, particles in 1 mole of each of these things. 1 mole of carbon, 6.022 times 10 to the 23rd particles. 1 mole of lithium, 6.022 times 10 to the 23rd particles of lithium. 1 mole of eggs, 6.022 times 10 to the 23rd eggs. Now realize that's a huge number. That's an incredibly large number. I don't even know what the name of this number is in terms of, millions, billions, trillions, quadrillions, all that. I don't even know what this number would be. It's so large. The reason is we're talking about things that are incredibly small, and if we're going to have any meaningful amount of them, we're going to have a huge number of them. But the second portion of the question, will 1 mole of each of these substances have the same mass? And the answer is no. 1 mole of one substance, meaning carbon or lithium or eggs, will not necessarily have the same mass as 1 mole of the other. Why? Because if we look at the periodic table, and I'm just going to round here just to make this simple. I'm going to round. Carbon is coming in at about 12. Lithium's coming in at about 7. And if we're trying to keep this on the same scale, if we had a mole of eggs, this is probably coming on the scale, and I'm talking about grams here. 12 grams, 7 grams. If we had a mole of eggs, we'd probably have, I don't know, however much a planet weighs. This is just a huge amount of stuff. Now, is the number of each particles in each of these samples different? No, we just established that we have the exact same number of particles in each substance. It's just that the mass of the individual substances is changing. Okay? One of the lighter elements, but still more massive than lithium, and then eggs. This is not an atom. This is a large enough object that you can hold in your hand. You can feel the weight of it in your hand. This is a large macroscopic item. To have a mole of these, it would be ridiculous. Okay, this is a very large thing.